Welcome to the deep dive. We take that stack of sources you gave us, the articles, the notes, all of it, and we really dig in to find the core ideas.
Yeah, it's the plant.
Today, our mission is all about energy and nutrients, how they, move through ecosystems. We're aiming to get a really solid handle on this whole who eats whom system.
Yeah, and it's more than just memorizing who eats what. It's about understanding the rules, the sort of ecological math behind why nature looks the way it does.
Like why there are so many plants, but fewer top predators.
Exactly. We're looking at the engine room, really.
Okay, and we're starting with something that feels, well, backwards almost. Energy is life's currency, right? You'd think nature would hoard every little bit.
Seems logical.
But here's the big question for this deep dive, and let's slow down for this one. If energy is the currency of life, why do we lose something like 90% of it? Every single time something eats something else. Where does it all go? Let's trace that flow.
That's the core puzzle. So we'll be looking at the food chain concept itself, then hitting that surprising inefficiency, that 10% rule hard. And finally, we can't forget nature's recyclers. They play a absolutely critical role in making sure the whole thing can, keep going.
Okay, let's unpack this then. A food chain. It sounds simple, but what are we really talking about?
Fundamentally, it's just a map. It shows the specific path that energy and also essential nutrients take as they travel through an ecosystem.
A path connecting the different players.
Exactly. Connecting the producers, the consumers, and eventually the decomposers.
Right. And where does this path always begin? According to the sources, it's pretty consistent.
It almost always starts with the sun. Doesn't matter if you're in a forest, the deep ocean, wherever. The sun is the ultimate power source.
The big battery in the sky.
Yeah.
But how does that sunlight become, food? Actual energy something can use?
That's where the producers come in. We're mainly talking about plants. They perform this incredible process, photosynthesis. It's like the planet's most important magic trick.
Yeah, pulling food out of thin air and sunlight.
Pretty much. They're like tiny solar-powered factories. They grab that sunlight energy and convert it, chemically locking it up as sugars, like glucose.
So they turn light energy into chemical fuel.
That's it. That's the absolute foundation. Without plants doing that, there's no energy base for almost anything else.
Okay, so the energy is locked in the plants. How does it get into the animals? So the next step.
Right. And that brings us to the first group of animals in the chain.
The ones that eat the plants.
Correct. We call them the first level consumers, or more technically primary consumers.
And since they eat producers, the plants, they're herbivores.
Exactly. Herbivores.
Their sources give a super clear example. Grass.
Mm-hmm.
Then an arrow pointing to a rabbit.
Grass rabbit. Classic.
And that arrow, it's important, isn't it?
Mm-hmm.
It's not just gets eaten by...
No, absolutely not. It specifically signifies the transfer of energy. Energy flowing from the grass into the rabbit that eats it.
Okay.
And this actually brings up a really good point for you listening to think about. Why are these herbivores, like the rabbit, so crucial? What's their essential job?
Well, thinking about it, if they weren't there, all that energy the plants captured,
Right.
it would just stay in the plants.
Exactly. It would be locked away, inaccessible to almost all other animals. Herbivores are the gateway. They're like translators, converting plant energy into animal energy for the rest of the ecosystem.
Okay, the energy doorway, I like that. So after the herbivores, the primary consumers, what's next up the chain?
Then we get to the higher level consumers, your secondary consumers, tertiary consumers.
These are the ones eating the herbivores, or sometimes even other meat eaters.
Correct. Carnivores who eat meat, or omnivores who eat both plants and meat.
So sticking with our example, we had sunnygrass rabbit.
Now add the fox. Fox rabbit.
So the chain is sunnygrass rabbit, fox. The fox eats the rabbit.
Making the fox the secondary consumer in this simple chain. It's getting energy that started with the sun, went into the grass, then the rabbit.
And then finally into the fox.
Yeah.
Okay. But here's what you said gets really interesting, right? The inefficiency part.
Yes. This is the big reveal.
Because that simple chain, sungrass, ear rabbit, ear fox, and maybe we add decomposers at the end, it looks neat, tidy, like an equal handoff each time.
It looks that way, but the reality is dramatically different. The whole system operates under a massive energy tax at every single step.
The tax.
A huge one.
Wow.
This is where we need that term. Trophic level. It just means feeding level. Producers are level 1, primary consumers level 2, secondary consumers level 3, and so on. And here's the rule, the key takeaway. As energy moves from one trophic level up to the next, Only about 10% of it gets successfully stored as, body mass, ready for the next consumer.
Wait, only 10%.
Roughly 10%, yes,
Yeah.
the other 90%. It's essentially lost to the environment from that level.
90% lost. That seems incredibly wasteful. Where on earth does 90% of the energy go? Did the rabbit just, like, nibble the grass?
Uh-huh. No, the rabbit probably ate plenty. But that massive 90% loss happens mainly in three ways people often don't think about.
Okay, what are they?
First, a huge chunk is lost just as heat. Every living thing has to run its basic life support, its metabolism, keeping warm, cells working. That burns energy, and that heat energy just radiates away. The fox can't eat the rabbit's warmth, right?
Okay, metabolism costs energy. Makes sense. What else?
Second, movement and other life activities. The rabbit has to hop around finding grass, escaping foxes.
And the fox has to hunt, run, stalk.
Exactly. All that activity uses energy. Energy spent on work, not on building more rabbit or fox biomass that the next level can consume.
Right, energy used up, not stored. Okay, so metabolism, movement.
Mhm.
What's the third big loss?
Waste and indigestible parts. Think about it. A rabbit eats grass, lots of tough cellulose it can't fully break down. That passes through as waste. And when the fox eats the rabbit, it might not digest the bones, the fur, maybe some complex proteins. That stuff also becomes waste. The energy in that waste isn't transferred up the chain, at least not directly.
Wow. Okay, so heat from just living, energy spent moving, and stuff that just can't be digested. That's where the 90% goes.
That's the bulk of it. It's not just a random number, it's the thermodynamic reality of life.
And that massive loss, that 10% rule, that explains the structure we see, doesn't it?
Perfectly. It leads us straight to the classic visual, the energy pyramid.
Right, the pyramid shape. Let's talk about that structure. It's not a cube, it's a pyramid for a reason.
Precisely because of the 10% rule. Think about the base. That's the producers, the plants. It has to be enormous.
Why enormous?
Let's put some hypothetical numbers on it, like the sources suggest. Imagine you need, say, 10 units of energy to support your fox at the top level.
Okay, 10 units for the fox.
Because only 10% gets through, the rabbits, the level below, needed to start with 100 units of energy to provide that 10 to the fox.
Whoa, okay, 10 times more.
And to support those rabbits, the grass, the level below them, needed to contain 1,000 units of energy.
So 1,000 units of grass supports 100 units of rabbit energy, which supports 10 units of fox energy.
You got it. 1,000 to 100 to 10. That's why the pyramid has to be huge at the bottom and get incredibly narrow at the top.
It directly answers that question. Why so few top predators compared to herbivores? And why so much plant life?
Because of that energy toll at each step, you need a vast amount of grass energy to ultimately support just one fox. It really highlights the constant struggle for energy, especially higher up.
Yeah, it suddenly makes perfect sense why things like tigers or eagles are relatively rare. They're paying the biggest energy price.
They absolutely are. But wait, the story doesn't quite end when the fox, lives its life. There's one more group.
The cleanup crew.
The cleanup crew, the great recyclers. We're talking about decomposers.
Mostly things like fungi and bacteria, right? That's their job.
Their job is absolutely vital. They make sure the whole cycle can start over again. When the grass dies, the rabbit dies, the fox eventually dies. Even when they just produce waste, the decomposers get to work.
They break down all that dead stuff and waste.
Exactly. They decompose it. They break down the complex organic molecules in dead organisms and waste products.
And why is that breakdown so critical? Can't new grass just grow?
But what does the new grass need to grow? It needs raw materials, nutrients from the soil, things like nitrogen, phosphorus, potassium. If decomposers didn't break down the dead stuff, all those essential nutrients would stay locked up in dead bodies and waste piles.
Oh, I see. The soil would run out of the building blocks plants need.
Precisely. Decomposers release those inorganic nutrients back into the soil, making them available for plants to absorb again and start the whole process of capturing the sun's energy. It's a beautiful loop. Energy flows one way, sun to life, but matter gets recycled.
Okay, that makes sense. The decomposers close the loop for the materials.
Couldn't run without them.
So wrapping this all up, what are the main things you, listening, should take away from this deep dive? First, food chains show the flow, right? Energy and nutrients moving along.
Yep. And that flow starts with the sun, goes into producers, plants, then through various levels of consumers, animals.
And crucially, that energy transfer is really inefficient. Only about 10% moves up each level, with 90% lost primarily as heat, movement, and waste.
That's the big one. The 10% rule shapes everything.
And finally, don't forget the decomposers, the fungi and bacteria. They're essential for recycling the nutrients back to the start.
Absolutely critical.
All right, now for a challenge, kind of like the group activity in the sources. We want you to do this in your head. Pick an ecosystem you like, maybe a coral reef, maybe a desert, maybe a temperate forest. Now design a simple food chain for it. It needs at least 4 levels. So figure out who's the producer at the bottom, who's your primary consumer eating it, secondary, tertiary.
And once you have your chain, think about the decomposer's role in that specific place. What does it break down, and why is that important there?
Good exercise.
And let's add one final layer to that, building on the source material's idea about adaptations. Think about that 10% rule again, how hard it is to get energy higher up the chain. Now, ask yourself this. What kind of special adaptation, maybe in hunting, maybe speed, maybe something about its metabolism, how it uses energy, would your top predator in that chain absolutely need to survive compared to, say, the herbivore at the bottom that can just graze? What's the real cost of being at the top? And what kind of amazing evolutionary tricks has life come up with to pay that price?